Hello, in this video I will show you how to perform a factor analysis using R for continuous data. Okay, so first let's set a random seed. Sample size is 200, although most factor analysis will do well with sample size about 100. Okay, so here let's say number of variables 8. So we create a data set with 8 variables and 3 underlying factors. So factor 1 is work environment, factor 2 is compensation, factor 3 is career growth. Okay, and so let's generate the 3 latent variables or factors, and we put the data into a data frame by generating the 8 variable using this set of linear equations. You can see the first 3 relate to work environment, then the 2 salary satisfaction and benefits package relate to compensation, and the promotion opportunity, skill development, the mentorship quality related to career growth. Okay, so first let's just do a correlation matrix. So this shows you about the correlation among all these variables. And by the way, fact analysis is also the the covariance-based analysis, which means we can perform the entire fact analysis by just using this correlation matrix. We don't actually need the raw data. Okay. All right. So before we perform a fact analysis, we need to check a few conditions. One of them is the Kaiser-Meyer-Okin, the KMO test for sampling adequacy. So this test is test whether the sample is adequate for fact analysis. So we can do that by using the library psych, and then we use the function KMO. Just feed the KMO function with the correlation matrix. We get the KMO result. And you can see the MSA here is 0.692. And the interpretation of the KM values, we got a set of rule of thumbs. So you can see here 0.9 to 1 is marvelous, and 0.8 to 0.89 is meritorious, and then etc. etc. And usually for good sampling adequacy, we want the KMO value is larger than 0.8. Okay. And the next condition we want to check is by performing the Bartlett test of sphericity. Okay, so basically what this does is to test the correlation matrix to see if it's different from the identity matrix. Okay, so what that does is to see if there's any correlation structure or redundancy in the data that make a fact analysis worthwhile and feasible. Okay. All right. So we basically want some structure inside the data set. Okay, because fact analysis has a dimension reduction component in it. Okay. So here to perform the Bartlett test, we use the core test.bartlett. Okay, LETT. Then feed it into the correlation matrix into this function, and then the argument n equal to the sample size, and then we can print out the result. So here the p-value is small, so we reject null, so we can it's justified that we perform further analysis using factor analysis or principal component analysis. Okay, the next thing for fact analysis is the Scree Plot. So I'll show you what this is. So we can get the eigenvalues, and then we put the data, the factors, and eigenvalues into a data frame, and then we can load the ggplot2 package, and then we can use the ggplot function, put in the Scree data as the object, and then the x equal to factor and the y equal to eigenvalues, and we say geometry line, geometry point, C minimal, and labels title Scree Plot, x is factor number, and y is eigenvalue, and then print it out. It looks like this. Okay. So what this is showing is, we can have up to the factor 4. After factor 4, then there's pretty much no additional variance was explained. Okay, so this tells us that we can select either 3 factors or 4 factors here. So let's do that. We can perform a factor analysis using 3 factors, and the rotation method is Varimax, which is a very popular choice. And then the FM, the method we use for estimation is the maximum likelihood estimate. The purpose of using this option is in case you have missing values in your data set, then it will estimate using the full information maximum likelihood estimate. That will work well if the data are missing at random. Okay, so just take care of the missing data issue. In our data set, we don't have any, but it's okay. We use the complete data using the maximum likelihood estimate, and we put everything into this FA underscore result. So how do we examine the factor analysis results? First thing is we look at the factor loading. And let's say cutoff 0.3. So basically we're just gonna showing the factor loadings with those factor loading that is larger than 0.3. If it's less than 0.3, we just cut them off. Okay. And this results in a very clear-cut factor loading pattern. You can see here ML1 and ML2, ML3 are 3 latent factors. And you can see the first 3 variables, they are clearly loaded onto latent variable 2. And the third and the fourth and the fifth variables are clearly loaded onto latent factor 1. Okay, and the last 3 variables are clearly loaded onto the latent factor 3. Okay, and you can see these factor loadings are very large, and they are all positive. So meaning they are all like contributing to the latent factor positively. Okay, they're only in the same direction. Okay. Sometimes you may have a contrast. Maybe some will be some variable will have positive loading, some will have negative loading. So some are adding more to the latent factor, some are like reduction. We have reduction on the loading on the latent factor. Okay, so this is a very clear-cut pattern. So the factor loadings, they represent the strengths of a relationship between variables and factors, and they range from -1 and +1. So they're like correlation coefficient. Okay, and the strengths is when they're close to +1 or -1 means very strong relationship, and if they're close to 0, then meaning weak relationship. In our example, we cut those weak off if the loading is less than 0.3. Okay. And the direction, you see the positive loading versus negative loading. It's just showing the direction, how they are contributing to the latent factor. And then if you square a factor loading, it's actually equals to the variance in the variable that it can be explained by that factor. Okay, so it is very interesting, sort of like R squared in the linear regression model. Okay, and usually we will cut off factor loadings. We keep those factor loadings larger than 0.7, and that means strong, and is less than 0.4 is very weak. Okay. Also, there's this concept called communality, which is the sum of squared factor loadings for one variable across all factors. So that's the variance in the variable that can be explained by all the factors. Okay. Remember, in the factor analysis, we always have fewer number of factors versus fewer number of variables. So there's a dimension reduction component there. Okay. So another component of the factor analysis results of factor scores. We can compute those by using factor.scores function and just feed it with the data set and the factor analysis result object. Okay. And these factor scores, if we print them out, you can see they have the same number of rows as the range of the data set, and then have the for each column, they say each factor, okay, latent factor. Well, these factor scores can be, they represent the estimated values of the latent factor for each observation in the data set. And we can do some additional cool things with the factor scores. For example, we can use these factor score for cluster analysis to identify clusters in the data set, or we can do outlier analysis to identify outliers. Okay, remember, these factor scores are standardized with a mean 0 and a standard deviation of 1 for comparison. Okay, and we can print out the factor correlation. These are the factors correlation between among themselves. So tell you. You can see they mostly is really very small, so that's what we want. Okay, so, and you can actually print out the factor loading diagram. So this is more kind of a precursor for the structural equation modeling. So you can see what variables are loaded on what factors. Okay. If you want to compute the communality, you can use the, just extract them from the factor analysis result, and the communality is already computed for you. The variance explained, so this give you the variance explained by each latent factor and also the cumulative proportion. Okay. All right, so this is a very basic factor analysis using R for continuous data. Thank you.